Welcome to Algebra 2. Algebra 2 begins with a review of topics you studied in Algebra 1. Some problems will be so familiar that at first you might assume the two courses are the same. They're not. Almost immediately the problems will become more interesting, and yes, interesting means more challenging. You will have to develop a good eye for detail and learn to choose the best method for working on the problem in a direct and organized way. The first two types of problems we'll review briefly use two words you've learned before, simplify and solve. They are not the same, so don't mix them up. In a simplify problem, you work with an algebraic expression, which has no equal sign. Simplify means rearrange what you have. So simplify means eliminate parentheses by using the distributive law, combine like terms, and then stop. Example 1 is a simplify problem. It has a number in front of parentheses to multiply and a second number in a second set of parentheses, and you'll notice on the end there's no equal sign because you're not solving an equation, you're simplifying an expression. When it comes time to do the solution, however, an equal sign suddenly appears. That's because you're going to be putting it in. Equals means continued on the next line, and there on the next line is the multiplication. I distributed the 1/2 to both parts of the parentheses and the -5/2 to both parts of the parentheses, and I opened up the problem so I could see all the parts. Then I had to combine the two like terms that were x terms, and I got 25 over 2x, and I combined the two numerical terms, and I got -17 over 2. And you can do this work, the multiplication and the addition, either on your calculator or on scrap paper in your head. That's your choice, except that you'll find that normally the answer to a simplified problem is in the same format as it was given. A fraction question gets a fraction answer. Although if you give your answer in decimal, no one will knock on your door and take you away. However, most students who see this example and see this answer have this reaction: yuck, a fraction answer. You don't like fractions, you want to cancel them out, you want to multiply the problem by 2, well, stop. In a simplified problem, no number can enter the problem that was not there originally. It's like opening up your piggy bank and taking out 50 pennies. If you want to, you can take it to the bank and trade it in for 2 quarters or trade it in for 5 dimes. 2 quarters, 5 dimes, or 50 pennies. They all look different, they're all organized differently, but they're all worth a $0.50. If you'd like to go to the teller and tell them that you learned in your algebra class that your math teacher said that any time you have 1/2, you're allowed to multiply by 2 and cancel out the fraction, and ask for a dollar bill for your 50 pennies, I doubt very seriously if you'll be successful. However, if you can find a bank that will give you $1 for 50 pennies, I want the name of the bank. It's worth extra credit. It's not unusual for a simplified problem that begins with fractions to have fractions in the final answer. However, never assume. Work the problem and wait to see what happens. Just to refresh your memory, this was example 1, and this was the solution to example 1. Now compare example 1 with example 2, which is also a simplified problem, except it has one very small difference. If you'd like, pause the problem and compare example 2 to example 1 and see if you can find the difference. Notice I started by writing the equal sign for you, although when it first appears, the equal sign won't be there. I distributed. I opened up the parentheses to see my like terms. I combined the x with the 10x and got 11x, and I combined the -5/2 with the -15/2 and got -20/2, and voila, don't you just love the French, I got -10. A problem that started with fractions didn't end with fractions. And I assume you all caught that little minus minus makes a plus thing that happened back here and happened again over here. It is not too difficult to make a problem in which the fractions complete each other and they're no longer in the final answer. Don't assume that a problem that starts with fractions will end with fractions. In real life, however, simplifying does not usually come on its own. That's for standardized tests and tests that test if you can master these skills. Usually simplifying is the first step in solving a math problem, and solving means equations. So just to remind ourselves, in a solving situation, we simplify, but we don't stop. We algebraically remove numbers so that we find out what x equals. In order to see the difference between simplify and solve, I took the expression from example number 1 and turned it into an equation in example number 3. In order to do that, I had to put an equal sign and a number after the equal sign. The equal sign is no longer just a symbol that says continued on the next line. It is now an integral part of the problem. I needed an equal sign and I needed a number, and I chose 11 because I thought 11 was kind of cute. Sad, I have no life. These are the kinds of things I do. In order to do the solution to this, I started out with a simplify step. I distributed just the same way I did before, and I got the same expression just the way I did before. And now, since the fractions bother me and I have an equation to work with, I can now do what I couldn't do before. I multiplied both sides of the equation by 2. That made a 5x, a minus 2, a negative 15, and a plus 20x, except now it equals 22 instead of 11. I made sure the two sides of the equation were still balanced, and that makes the whole thing kosher. Add 17 to both sides, divide by 25, and there's your answer. X is 1.56. So we did a combination of simplifying and solving, but we moved numbers and rearranged numbers and changed numbers, because in an equation, as long as we did the same thing to both sides, whatever we got as a result was a legal mathematical answer. And yes, I did get a decimal answer. Decimal answers happen the same way fraction answers happen, or I should call them solutions. The person who writes the problem, and that's me, gets to play with the numbers to engineer almost any solution that he or she wants. Example 3 looked like this, very much like example 4 and example 5 look at first glance. However, I made some tiny little changes to these two examples just to prove a point. And very big thank you goes out to Mrs. Teichman, because she made sure that I got the right answer to example number 4. I wanted you to see from these two answers that sometimes you can get whole number answers, sometimes you can get decimal answers, and sometimes you can get fractional answers that can't be written in decimal form, and they can be negative instead of positive. Anything can happen when you're doing a math problem. So please don't assume that problems that look very much alike will come out with answers that are very much alike. It is very sad to watch students change the right answer into the wrong answer because they decided that it didn't look right. Algebra will never let you down as long as you follow the rules. Just work the problem. So again, welcome to Algebra 2. May the odds be ever in your favor, and thanks, DeVoe.